afternoon, everybody.
Hello.
We have brought in the former club president of Quantum Computing Club, Samuel.
Hi.
Samuel. He's also one of the founders of it. He will be giving a speech on independent research as a student, and thank you for coming.
Thank you.
Professor, would you like to say?
I wanted to say a few words. It occurred, no, stand up here. It occurred to me, when I read the abstract, which is on the poster, and knowing Samuel and like reading your paper a few months ago when it came out and all, even though I haven't seen much of you, at least somehow I've stayed in touch. I don't know, LinkedIn or whatever.
Yeah, exactly.
So, and of course, Matthew's still here, and all the Matthew. It occurred to me, you wouldn't think so, but these guys have a lot in common. in any observable way, they're nothing alike. But they have many good things in common. First of all, they're both calm people. They both do whatever needs to be done, right? They do their assignments, whatever they need to do, they do it. And they do it well. But both of them go beyond. Each of them does very unique things that nobody, as far as I can tell, asked them to do. They show a lot of initiative in ways that distinguish themselves, which I think is great, and I think that's a great example for you guys. Number one, do everything you're told. Right, my students, please. But when your applications get to College Park or Towson or wherever you're applying to, got 3,000 of you that all look alike to the admissions counselor. You got something different on there. It makes you jump out, like, whoa, here's something that's different. Stuff Samuel's going to talk about is I think, pretty rare that someone at your stage has done. Certainly, you've probably all heard bagpipes in the hallway and seen him walking around in his kilt. So that's a little bit unusual too, but a great thing that makes him stand out. I met admissions counselor from GW many years ago. And I said, what does it take to get in? And I said, be really good at something that you're doing. Whatever it is, be really good at it. Get awards, get some recognition. And the example that she used is, if basket weaving is your thing, be the best at it. Go to conferences in basket weaving. Go to show, get a ribbon in basket, and put that on your application. Make you look different. These guys, they look different. Their resume, their whatever, stands out. And that's a great model for you guys. So that's why I wanted you to see the similarity between these guys. So thank you for coming. In about a half an hour, pizzas will show up. And there's soda and drinks out there. So again, thank you for coming.
Thank you so much, everyone, for the opportunity. It's really a pleasure, and I'll just say that it's so crazy to be here back. I know that it's only been a couple of years, but being here again at the rooms where I remember that while I was a student, I had a couple of presentations here too. So being back here, talking again to the professors, to the people I've seen while I was in these years, it's amazing. So thank you so much for the opportunity, and thank you so much to the Quantum Computing Club for the opportunity to reconnect. Okay, so today I wanted to talk about how to become an independent scientist as a student, which is something that can be very useful for the people, especially for the people who are thinking about getting into research as a career. So, in all my talks, I always like to give some takeaways at the beginning so people can have already some learning before getting into the topics. So my first takeaway is that every student here in this room, everyone, has the ability, has the potential of creating new knowledge, which is something very important in research. Also, my other takeaway is that your ideas can be way more powerful than what we expect. And my third takeaway, and I really want to make this one very clear, is that you don't have to wait for permission to start doing the research, especially when you're a student. You don't have to start to wait to get permission. You can start by taking your first step. So before I get into this, I have to talk a little bit about myself. That's the first part of the outline. I have to give some context about myself, who I am, what's my story, so then I'll be able to share what I learned from that story to everyone here. Now, if you also look at this outline, you'll see that there's a main idea that I also want to share with everyone, but I'll keep it for now as a secret, and then I'll share it as my conclusion for the last part. So, I was born in Venezuela. I'm Venezuelan. And I lived in Venezuela for most of my life. I lived there, I'll say, continuously until I was 14. Then I went a couple of times to Colombia and Ecuador, but essentially my main experiences are from Venezuela. And then when I turned 14, I moved to Brazil. That was because my dad, he found a contract in Brazil. So we lived a couple of years there. And then we came back to Venezuela, but because of a long story that I don't want to get too much into because it'll make the talk way longer, crises and stuff in Venezuela, we ended up moving here to Maryland, where I did my young adulthood and where I got my most experiences in my career. Now, we can divide my story as this map right here in 3 different parts. So where I shaped my childhood, where I shaped my adolescence, and where I shaped my young adulthood. So talking about my childhood, that is a picture that, that I had to get for the slide. I was born in the city of Coro, which is a city in the coast of the country. But then I was literally just born in the city. Then I moved to Barquisimeto, where I lived most of my life. And I studied at Colegio Educación, which is one of the high schools are in the country. Like, it's very next to one of the biggest malls in the city. And actually, something funny. Maybe if you know the advocate from MC, you'll realize that the logo is very similar, so I realized that when I started studying here. And when I was in Aplicación, I used to be a regular student. In which way? I used to have good grades, and I do remember teachers going and congratulate my parents because I used to take care of my academics, of my schools, of my homework, etc. But the thing is that I didn't used to go beyond. Now, if I think about this, I'll say that probably the reason why I was so focused back then when I was a child at school and all that is that because I used to be a bit shy back then. So I didn't used to do things like kids of that age normally do, like talking in classroom or playing around classroom. So I used to dedicate more of my time to that. So that's something that I really appreciate about Colegio Educación, that it gave me the idea of taking care of grades. But as I said, I didn't used to go beyond that. And not only for research, especially for every field that you want to get, that you want to do, only grades is not enough. You have to do more than that. Now, I don't want professors to get mad at me right now. Of course, also getting good grades is very important, but it's not enough. You also have to do more than that. Now, I want to share also on that just that everyone can have an idea of where this story happened. Barquisimeto and Coro, the 2 cities where I live most of my time. Part of my family is from the capital, Caracas, so I included it on the map. And I also wanted to include this town of Portoderos because I used to go a lot when I was a child, so it's nostalgic to me, so I wanted to include it. Then, next, I ended up moving to Brazil, and I lived 2 years and a couple of months maybe in Brazil. I lived the first year in a city called Uberlândia, in Minas Gerais, and then I moved from Uberlândia to Curitiba. And this is a picture of me when I was back in high school at that time. And the thing is that I had trouble trying to find a good picture because it was very embarrassing for me to find a picture, but I thought like, hey, maybe that one looks good enough, so I'll do it. Now, when I was in Brazil, I did my first year in Gabarito. And something that I really appreciate about these 2 high schools that I went to Brazil is that teachers there were a bit different too. I feel like, for example, in my school, teachers used to be a little bit strict, like old class teachers. In which way? They used to try to scare students in order for them to do well in class. Like they used to say like, hey, don't do this. They used to scream to students, all that. And I mean, essentially when you're a child, like I feel like it makes you try to do the things in order to avoid that instead of actually being engaged in what the professor or what the teacher is talking about. So something that I appreciate about these high schools is that I had the chance to meet teachers that didn't used to be that strict in that way. So I used to engage with what they used to talk about. And then that was Gabarito. And then in Pagosi, it was pretty much the same. But in Pagosi, I had the chance to have my first contact with physics, officially my first contact. So when I was in Pagosi, that was when I took my first physics class in high school. If I'm not wrong, I believe that we were talking about kinematics and energy, like basic physics. So that's when I started to engage with this. And also, in this picture that I have right here, first this is me, I have to point it out so everyone can see. She was not my physics teacher, she was my math teacher actually. Her name was Rosa, but we used to call her Rosinian. And I really like the way that she used to teach the class. Like, the way that she used to make students engage in what she was talking about, it was really interesting. That got me into wanted to work with numbers, wanted to do something with this field. So I actually remember one of her classes, I made a question. Like, hey, she was talking about functions and graphs. It was the first time that I was seeing a graph. And I asked her, hey, does graphs go to infinity? Now, if we think about that now that we have some background in math, we know that, yeah, of course, all graphs can grow to infinity. But I didn't know back then. Now, if I was like thinking, as I was telling before, only thinking to have grades, I wouldn't have asked that question to her. I would just say, hey, this is a graph, you can draw functions on it, period. But that was a sign that I was getting into something else. And then also another thing that I'm not mentioning on these slides is that back then, I also used to watch some videos on YouTube about physics. Probably some people that know about the Hispanic culture, the Hispanic internet culture, know about quantum fractures, Ciencia, Javier Santolaya. I used to watch their videos and they really got me into doing physics. This may be a bit more beyond, but I did 1 year through the prep program of this, and I had the chance of doing an article talking about my story. In that article, I mentioned that it was Pokemon and it was video games that got me into numbers. Now, this is true, but if it was only for that, if it was just because I used to like that as a child, probably I wouldn't have count that as a reason to get into this. Because it was just something that I liked as a child. It was also because of the encouragement of these teachers and also because of the motivation that I got from these videos that I decided to take a step into this field and hey, I want to be a scientist or physicist. Map of cities as well, this is Uberlândia, this is Curitiba, they're pretty much south of Brazil. If it was for me, I would love to travel more inside Brazil, but I was in high school back then, so I didn't have the money and I wasn't old enough to travel. And then this is me. I went then to Venezuela, and then after I did Venezuela, I moved here to the US. This is me during my first semester at MC. You can see the mass. It was during the first time that MC was open after COVID. So when I got here, I didn't know the language. I didn't know how things were done here. I knew nothing about this place. But my parents hear that MC also does some English non-credit classes for immigrants, for people that are here with non-student visas, and we went there to start learning the language. And I remember one friend from that class told my dad, like, hey, you should register your son to MC, because at MC there's a lot of opportunities, and also he'll have the chance to start getting into his career, into what he wants to do. So I ended up moving to MC. Here when I was at MC as a student, I did my associate in physics, and I also did an associate in computer science. Then I applied to the prep program at NIST, and I did a year of research. and also I have some experience doing honors research projects at MC. And then, after I finished here at MC, I moved to UMD, University of Maryland, where finally I'm about to get my bachelor's in physics. I'm only a couple semesters away, so please wish me luck for this finals are coming up. And then, and then during that time, I'm also doing research at the QMC, the Quantum Material Science Center at UMD. And this is some pictures about me during these years. This is me at one of the labs that I used to work at NIST. This is the research group that I had while I was at NIST. This is a picture that one of the first flyers of this club. I remember that this is a picture when I was doing one of the first flyers that we were looking for members. So I had to include it for this year's. This is a picture of me graduating from MC. This is me working at the lab. This is me doing physics. Electrostatics. Yeah, this is a picture of me doing electrostatics. This picture, I also had the chance in my years at UMD of going a couple times to conference. I went one last year, and I went another one at the ending of August, if I'm not wrong. And the conference was SACNAS, is the Society of Advancing Chicanos, Hispanics, and Native Americans in Science. I had the chance to meet the executive director at the airport, so that's us taking a picture at the airport. This was in Phoenix, coming back here to Maryland. And this is a picture of the first article that I got published, that I also wanted to include in the slides. So I had a long journey. I went through 3 different countries. I went through 3 schools. I went through MC. I went through a national lab. I went through UMD, and I also went through a research group inside of UMD. So I mean, I still have a lot of work ahead of me, but I can tell by now that I had a long journey. But what did I learn from this? Now, this is the thing that I want to share, what I learned from all this journey, to share it with everyone here in the room. But before I do that, it's very important to give some context so everyone will be able to understand those learnings that I want to share. So now what I want to talk about is what is research and why should we do it? Something really quick, I need to get my notes for this part. Because this part is a bit long inside. Almost done. Okay. So, according to the Cambridge Dictionary, the word research is defined as a detailed study of a subject, especially in order to discover new information about something or reach new understanding of it. Now, a lot of people think, especially students, a lot of people think that doing research is going to a professor and asking, hey, can I do a project with you? It's maybe, hey, getting into a national lab or getting into an internship in a lab, or it's maybe doing a PhD and doing research while you're at grad school. A lot of people have that idea, but essentially, our job as researchers is trying to find new information, being able to understand it and share it with other people. So, what can I say from this? Is that there's a lot of misconception in the world of research in this way. So this is something also that we need to make clear that, hey, research can be a career, of course, you can be a scientist and you can do research, but also we all do research. When you want to know about something, you have to do research, maybe going through books, maybe going through internet, maybe, I don't know, asking ChatGPT or something to get that information, and that act is research. And it's something that has shaped society in a lot of ways, because it's the way that we as humans get information. Now, why should we do research? My first point is that humanity only progresses by embracing the unknown. My second point is that because the world is made by the discoveries of yesterday. And my third point is that because your ideas can shape the future. What do I mean by this? One thing of research is that it works by creativity, by ideas. In which way? So there's people that talk about this idea that, hey, people are divided into two parts, if we can call it this way, into a more creative part, maybe an artistic part, people that do drawing, etc. And there's part of people that it's more like mathematical, more scientifically, more dedicated into science. I don't think that this vision is wrong. Because actually, believe it or not, in science you do need creativity to get new ideas. And everyone in this room has different ideas inside of their mind. So that's why we should do research, because we can afford our ideas into this field to fighting, to getting into those answers that humanity haven't been able to find yet. And now, one good example that I want to share about this is Peter Shor. Of course, in science, there's a lot of examples of this, but this is at the Quantum Computer Club, so I wanted to share an example related to quantum computer. So Peter Shor, probably a lot of you guys have heard of him because of the Shor algorithm. He wasn't working trying to find specifically the Shor algorithm back then, because there was no quantum computers back then. There was no technology of this field. He was only wondering something. Is it possible for quantum algorithm to be better than classical algorithm? Can quantum do in this way process information better than classical? So he wondered that by himself, and because of this idea that he had even before quantum computers existed, he was able to make this algorithm that we use today in this field. And now, the lessons. So what are different lessons that I have learned through this year that I want to share with everyone? So there's a book that I read at the beginning of this year that everyone who wants to do research, I would highly recommend to read this book. A PhD is not enough. So this book was made by this guy right here, Peter Philman. He's a senior physicist at Sandia National Laboratories. And he used to talk, he used to give some advices for people to survive in this career, like, hey, talk to advisors. I remember, even for example, that he mentioned, hey, try to find senior advisors, because seniors tend to let you grow more by yourself because they have already done their careers than young advisors. That's what, for example, one advice that he gives in the book. But he talks a lot about this, like the importance of having independence in research. And believe it or not, if you want to go into this field, you have to have some independence. Why? Because you can do everything perfectly. You can go to school, you can have good grades, you can do an internship like I did, for example, at NICE or somewhere else. And if you're not able to come up with your own ideas, you'll be someone else in this field. There's a lot of people around the world dedicating their lives to research. And if you're not able to find your own ideas, you'll be just one more of them. Now, the lessons that I want to share, for example, the first one, start with what you have, your curiosity. So, also, I have some space here, so you guys saw some links that I put there to fill that space. So, curiosity. Well, research begins with the curiosity and asking your own questions. Independence matters more than having a big lab or expensive equipment. And what do I mean by this? Every big idea starts on paper. It's right that you can go to a very fancy lab and you have all the equipment, all everything that you need to do experiments, all the resources, all the funding. But the ideas that you want to do research on those equipments and those fancy labs, people made them first on paper. So if you want to do research, if you want to use those equipments for something, you have to have ideas to know, hey, what do I want this experiment to look like? So, for example, the students, usually something that happens to students, and it happened to me too, is that you go to a lab, to a very fancy lab, and you have an advisor, and the advisor says, hey, read this paper and do the experiment to see if what the paper says is true or not. So, right, you get some experience reading articles, you get some experience using the equipment, but you don't make your own questions. You're only repeating what people is telling you to do at the end. And very important, start creating your own ideas instead of waiting for someone to assign those ideas to you. Also, something very important that I want to share, the Spanish speakers maybe that know about the Hispanic culture on YouTube know this guy, Javier Santadalla. He was one of the examples that I mentioned at the beginning when I was talking about my story. He's a Spanish physicist, engineer, and site communicator on YouTube. And he has motivated me a lot to go into this field. One quote that I want to share from him is, knowledge is one. What does knowledge is one mean? So, you can learn about things that you do, that you like to do. You can do research in a certain field and read about that field, but you can also go beyond that. You can read, for example, about a different topic. You can go, maybe you're doing physics, you can also go and read chemistry articles. If, for example, if we take this to class, you can read more topics of the class in advance, or go to read another classes. You can, knowledge is only one step, and you don't only have to limit yourself to STEM. You can also read about art, you can read about literature, you can read about anything that you like. And when you do that, you have different ideas, different points of view for different fields that you might be able to connect and make a new knowledge out of it. So that's why I wanted to share that quote from you. Then build your scientific identity early. And this is very important, especially for the people that are going into PhDs, because then you'll have your advisor and you'll have to do research based on that. So try to make your own identity. And also it's very good for to apply for applications into grad school. So do not limit yourself to just following your advisors or your classmates. Try to do more by yourself too. Start doing projects that reflect what you like and what you want to explore. And your identity starts right now. You don't have to wait until you go to grad school. You don't have to wait until you do your PhD. You don't have to even wait until you get an internship in this field to start thinking like a scientist. It's something that anyone can learn how to do in this moment right now. And also, never, and I want to make this one very clear, never wait for permission to start doing research. If you're not able to find opportunities, especially in the field that you want to do, you can be able to create your own opportunities. And this is actually an example that I want to share later, because I will share some examples from my own story that apply to all these lessons. But this is something that I learned, and I think that it can be very useful for everyone in this room right now. Do not wait until you get permission to do research into your desired field, because you can do also things independently. And then the last lesson that I want to share for these slides, then I'll share the secret one, is never keep your ideas for yourself. So you can do research, you can do your own project, you can even have an idea that might be able to get a Nobel Prize, but if you do not share it with someone else, those ideas will only be for yourself. So something that I really want to say is that please talk to your professors, please talk to classmates, fellow researchers, etc. Try to publish in research journals. There's, for example, some journals that take articles from students that you can do. And also try to go to a scientific conference. Now, one good thing that it's true about scientific conferences is that you get the chance to do networking with other people. You can meet professors, you can meet researchers, you can meet scientists from different institutions. It will be helpful for you to do networking. But this is a talk about research, so it's true, but I'm not going to get too much into that. The other good thing about going to conferences is that you have the chance to share your ideas with other people, with professionals in the field that you're going to. So now, also another thing is that Arvix is a preprint journal. I also tried to get this article published in one research journal, but I also wasn't looking enough. Now, I know that, what do I mean by not looking enough? I do have journals that I talk to, but the problem is that I am right now a student. So if I want to get published one article that I made by my own, no article is going to take it if I'm just a student. I need one professor to review it and say, hey, this is good, I need an advisor. So I was sending a lot of emails around the physics department at UMD saying like, hey, I'm a student, I did this project, I want to get it published, I need to find a professor, please, can you take a look? Nobody answered back to my emails. So that's the reason why I haven't got it published yet. But then I thought, hey, I have this paper in my computer for 1 year before I get it published. And besides those professors that I tried to contact, nobody knows that this paper exists. So why don't I try to get it published in Arbix? It's not officially a research journal, it's a preprint journal, but at least other people will be start to look at this paper. Other people will be able to read it. And who knows, maybe in the future you have someone that gets interested in this and say, hey, I want to be your advisor to get this paper published. So I did this, and thanks to it, I had the opportunity to reconnect to the club and tell this talk. And another example of my story that I want to share that I think that it's not, well, I think no, it's not pretty much quantum information, but it's a very good example of what I'm saying right now, is the numerical Corbata system. Now, I'm going to be very light on this. It's basically a project that I started working when I was an MC in a Beverly as well. I wanted to do like a ciphering system at the beginning. And I saw different ways to how to do that. And I ended up making probably, the thing is that the picture is too small. Well, this is a picture, well, I remember I took this picture actually here on MC. What I did basically at the end was a diamond, and that diamond I divided into 25 pieces. The problem is that the English alphabet has 26 letters. So if you want to have all letters inside that diamond, it's not possible. So I ended up adding an extra diamond on top, and that's why I call it corbata, because it has a corbata shape. Corbata means tie in Spanish, so it's the tie system. And yeah, it was a basic ciphering system. Then you can arrange words from up and down and all that, and you get all these words, ciphered words here. But one day I thought, hey, what would happen if instead of using letters, we use numbers? So I changed all the letters for numbers. Probably here, it's still small, but you guys can have an idea. I started to put all numbers there, and I thought, well, and then I started to think, hey, what is this? Is this something like Pascal triangle? Is this something, what is this? I don't know. And then I realized every number appears only once here. Every integer, I'm still trying to look how to do decimals, but for now it works for integers. Every integer appears here only one. So it's the same like the number line. Everyone knows the number line, a straight line, and it has 0 in the middle, and then it goes 1, 2, 3, minus 1, minus 2, minus 3. You use that as axis to make graphs. So it's the same, but I'm making numbers, I'm putting numbers in a different pattern instead of a straight line. So I started to go over that. I started to make a project by myself about that. And then I had the chance to go to the conference last year that I mentioned. On that conference, I did a presentation just talking generally about the corbata. Like, hey, this is the corbata, this is what it is, you can do this is the properties, etc. But I did that presentation because I wanted to exchange ideas with other people to try to find new projects to work on with this. And then I remember one professor that I met from Ohio State, he told me, hey, why don't you try to get the corbata, get this plane? Oh my God, I need to look at my slides again. I was trying to point at this one, I have this big one here, I'm sorry. Well, it was right behind me, so that's why I didn't see it. Yeah, you can, this better. What will happen if you, yeah, he told me, why don't you get the corbata and try to match all prime numbers in it. So if you start to look and match 2, match 3, match 5, and mark all other prime numbers, and then try to get a pattern out of it. So if you're able to find a pattern with these prime numbers, and prove that it's a pattern, you could extrapolate it to infinity and follow it to be able to find every prime number that exists. And this is something that is huge in mathematics. It's something like find a holy grail in mathematics. Because even though prime numbers are so important, there's no function, there's no equation that outputs all prime numbers. So yeah, I did that. Then I went this year to the same conference. I did this presentation. This is a picture of me doing the presentation. And this is the tiny corbata with all prime numbers marked. And when I was doing that presentation, I met a guy from University of Mayagüez, Puerto Rico, which is one of the largest schools in Puerto Rico. And he's, if I'm not wrong, a master student in that school. And he told me that he works with prime numbers, and he said, hey, let's keep in contact. Because I see that your project, your method, will actually be useful for my own work too. So now, I see that I made a legacy in mathematics. Maybe it's small, because nobody knows what the corbata is still. It's still, I'm still working. Nobody knows by now yet, a lot of people, what is a corbata. But I have now another person working on it too. So right now, I can just stop doing the corbata at all. I can just dedicate all my whole life to physics or just to being a student and get good grades, not doing research at all. But I'll have someone else who's doing also research on this. So it's something that now goes beyond. So that's why I feel like it's a really good example for this. And now, the last part. What's that secret idea that I want to share? So I talk about different things. Talk about being independent. I talk about conferences, professors, etc. But I still have to mention what's that idea that I want to say for the end as my conclusion. And that idea is your ideas today can become tomorrow's science. So, as I said at the beginning, research is based on ideas. And everyone here in this room has ideas. So, the moment when you start to put those ideas into this field, you have different point of views about one problem. And you might be able to find one solution for something. So if you're able to find something that helps for other research in the future, if you're able to find something that is actually useful, you'll be able to make a legacy. And you'll be able to change the science of tomorrow. Because the science of tomorrow is based on the discoveries of yesterday. So what I want to say with this, that it's very important that I want to make it clear as my conclusion, is that for everyone, this goes for everyone, your ideas right now might become the knowledge that the students of the future will be learning in class. So that's the idea that I wanted to share with everyone. Thank you.